Processing container values often involves iterating over all of the values contained in the list or dictionary that you're interested in. But there are some functions built in that help us do this more efficiently. In particular, there are several functions that perform sequence aggregation. So these are functions that take iterable arguments and aggregate them into a single value. I'm just going to show you the actual documentation in Python 3 and help you understand how it works. So there's a built-in function called sum, which takes an iterable argument such as a list. Now, this notation doesn't actually mean you write square brackets when you call it. Instead, this is something that's used in Python docs to say that the second argument is optional. So you can call sum with just one argument, a list, and it will sum the values, or you can call it with two arguments, a list of values, and then some start value. And it will go through all of the values in the iterable and add them to the start. Okay, so here it says, return the sum of an iterable of numbers, not strings, plus the value of parameter start, which defaults to 0. When the iterable is empty, return start. Sum 2, 3, 4 is 9. Sum 2, 3, 4. It doesn't work with strings. Now what's the starting value about? Well, if I started with 5, then I would add 5 and 2 and 3 and 4. Now why is that useful? Well, let's say you're adding together values that aren't just numbers. You have to provide a value of that type in order to get started. So remember that I can add 2 and 3 the list to 4 the list, and I get a longer list. Well, in the same way, I can sum a list containing 2 and 3 as well as 4, as long as it's the case that I start with a list in the first place. If I hadn't started with a list, I'd try to add this list to the number 0, and that's not possible. So that's what would have happened if I had summed without that starting value. But since I provided an empty list to begin with, and then I added in 2 and 3, and then I added in 4, I ended up with a list 2, 3, 4. Max takes two forms. You can pass it an iterable, such as a list, as well as an optional key function, and it returns the maximum value. Or you can pass it multiple different arguments, such as a bunch of numbers, along with a key function, and then it will take the max of the arguments. So it says, with a single argument, return its largest item, that is an element of the list that you pass in. With 2 or more arguments, return the largest argument. So the max of a range going up to 5 is 4, or I could have said max 1, 2, 3, 4, with a 0 at the beginning, and that would have done the same thing. Now what's going on with this key function? Well, the documentation didn't tell me, but what happens is that it applies a function to every element that you're considering, and actually computes the maximum based on the return values of calling those functions. So you can ask things like, what's the max value in the range from 0 through 9? If what I care about is some algebraic expression, like 7 minus x minus 4 times x minus 2. Now that's some parabola where the maximum's right at 3. If I designate this as my key function, then it's going to tell me the maximum value in this range as an output of calling this function is 3. So if I take this function and I apply it to the number 3, then I get 8. But if I applied it to 2, I'd get something less. If I applied it to 4 or 5 or 6 or 7, I'd get something less as well. So that's why it's giving me the return value of 3. Here's a third one called all. All takes an iterable and returns true if you get a true value when calling bool on every element in the iterable. If the iterable is empty, return true. What's this bool function? Well, bool tells me whether a value is true or false. So 5 is a true value, True, of course, is a true value as well. Even -1 is a true value, but 0 is not a true value. It's a false value. Likewise, hello is a true value, and an empty string is a false value. We learned about these when we talked about Boolean contexts back when we introduced conditional statements. So what about all? Well, let's say I have range 5, and I want to ask, is it the case that x is less than 5 for x in range 5? I'd get true, 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 true. The goal of all is to aggregate those together and tell me whether they're all true or not. I don't have to pass it a list of Boolean values. I could pass it the list of numbers 0, 1, 2, 3, and 4, and it would tell me that since 0 is false, these are not all true values. So those are 3 built-in functions that operate on sequences. There's also min, and there's any, which are complements to max and all.